Hi students, welcome to lesson 1.3, using midpoint and distance formula. Now in the first part of the exploration, and by the way, we're on page 12 of your student journal. What you have here is 2 points, A, which is coordinate 3, 4, and B, which is coordinate -5, -2. Now for this lesson, you're going to need these materials. You're going to need your protractor, and you're going to need 1/6 of a piece of graph paper. So make sure you guys have that handy. So if you don't have those, please pause the video and make sure you get them. So you need one of these. I'll tell you where they're going to be glued in just a bit. So what I want to know about these 2 points is, where is the middle point? Now, it's an easy enough coordinate, so where you can actually kind of eyeball where they're going to be. So first thing I'm going to do is I'm going to draw a line segment between those two. Oops. Shaky hands. All right, so there's your line. So where exactly is the midpoint between these two? Now, I know you're going to say, well, it's right there, because that's where it looks like it's going to be. But we are actually going to calculate it. And let's talk about the equation of a midpoint first. Now, the equation of a midpoint, all it really is just the average of the x values and the average of the y values. And that is the equation that's going to give us the actual midpoint. So the equation looks like this. If you have 2 coordinate points that we're going to call x1, y1, and a second one, x2, y2. Those are my 2 coordinates. Now, I know these are the coordinates we have here, but we're making it in a generic case. Now, the midpoint between 2 points is the average of the x's and then the average of the y's. So like this, x1 plus x2 divided by 2, y1 plus y2 all divided by 2. Very, very simple. All you got to do is identify what are the x values, what are the y values, and then average them. So let's look at this example that you have right here. Here you have A, and the coordinate of A, whoops, let me lift it up here. The coordinate of A is 3, 4. The coordinate of B is -5, -2. So what's my x1, what's my y1? It's totally up to you. If you want to make this one your x1 and this one your x2, you can do that. Do you have to label them? No, but if it helps you, go for it. x1, y1, x2, y2. I would do it just in case, because you're going to be doing the distance formula, and it kind of helps to get used to, assigning variables, not variables, but like subscripts to these x and y values. So let's go ahead and find the midpoint. Now, looking at the equation above, you have x1 plus x2. So x1, that's 3, x2, that's -5. So you have 3 plus -5 divided by 2, and 4 plus -2 all divided by 2. After this is just simple math. 3 plus -5, that is -2. 4 plus -2 is simply 2. So when you reduce these, your midpoint is going to be -1, +1. So that, ladies and gentlemen, is your midpoint between those 2 points A and B. Now, you were eyeballing this coordinate right there, and yes, you were right. But keep in mind that you will not always have this luxury. Sometimes your midpoint is going to be anywhere not in a coordinate where both the x and the y are integers. All right, let's turn to the next page, page 13. Now on page 13, you have the same graph. But now what we want to do is we want to find the distance between A and B. Okay, so we're going to make this into a right triangle. Now, yes, I know I can count and easily use my Pythagorean theorem, but I want to practice using the distance formula. Now, the distance formula looks something like this. The distance is equal to the square root of the differences of the x's, quantity square, plus the differences of the y's, quantity square. Now, where the heck did this equation come from? It pretty much comes from Pythagorean theorem. This distance right here happens to be the distance from here to here. This distance right here happens to be the difference from here to here. Kind of like your A and your B. And in this case, your distance is your C squared. So when you square root both sides in the equation, you end up with the actual distance. So now what we're going to do is we're going to find the distance of this segment given the coordinates that we have. So for A, again, you have 3, 4. And for B, you have 5, -5, -2. So now what we're going to do is we are going to substitute those values into the equation. Now, I don't always follow the questions that they have here. I just like using the space for it. So if the answer of what I'm putting in here is not the answer to this, don't worry about it. It's just space for me. All right, so what we're going to do is let's plug things in. But before we do that, let's label. We're going to call this one x1, y1, x2, y2. After this, we're just going to substitute the values into the distance formula. Okay, so x2 minus x1, be careful with your signs. I always like doing this because I know when people don't do this, they always forget their signs. Get a little space here. Oop. Give me 1 second. Got some technical difficulties. My pencils. Okay, I'm back. Okay, so I would set it up like this with your minus signs right there. That way you don't forget anything, because sometimes you forget the square, sometimes you forget the add, sometimes you forget the minus signs. So x2 is -5, x1 is 3, y2, that's -2, and y1, that is 4. All we need to do now is simplify. -5 minus 3, that's -8. -2 minus 4, that's -6. Now square these. That's 64, and that's 36. So the sum of those two numbers is 100, and it just so happens that this is a perfect square. Therefore, the distance from A to B is actually 10. So AB is 10. This will not always happen. Sometimes you're going to get an integer, sometimes you're going to get a decimal. If they want you to leave it in radical form, leave it in radical form. Sometimes they might even ask you to leave it in the simplest radical form. And that's something else that we're going to be covering on later on. Okay, so let's go ahead and turn to page 14. All right, just so you know, problem 1 is going to go right there. Now, let's talk a little bit about midpoints and what are segment bisectors. So, the midpoint of a segment is the point that divides the segment into two congruent segments. We already talked about what congruent means in the last lesson. So here you have a segment AB, M is the point that divides that segment into two congruent segments. Boom, right there. Now that means that AM and MB have the same distance. Therefore, they're congruent. Therefore, we're going to mark them with a little hash mark. So M is the midpoint of AB. So AM and MB are congruent. Therefore, their lengths are the same. Now, a point is not the only thing that can cut a segment in half. You can have, besides a point, you can have a ray, a line segment, even a plane can intersect a segment at a midpoint. Okay, a midpoint or a segment bisector bisects a segment. Okay, bisects just means cuts it in two. Okay, now in this diagram, you have a line, and this line is the segment bisector. So here you have line CD is the segment bisector of AB because AM and MB are congruent. And by the way, example number 2 is going to go right there. And this is still on page 14. Now, really quickly turn to page 15. Now, this kind of gets a little complicated on how I got the equation for the midpoint formula. Midpoint formula is right here. We already used it. In this space provided right here, divided up into two parts. This is going to be for 3A, and this is going to be for 3B. Now down here on number 4, that is where you're going to need your 1/6 of graph paper. So go ahead and pause the video. Go ahead and glue the paper to the bottom right-hand corner of the paper as far as you can on this side. And that's going to be for problem number 4. Now we are ready to start the examples. So let's start with example number 1. Okay, here's example number 1. In the skateboard design, VW bisects XY at point T. Now, I don't know if you can see it, but there's two little hash marks right here. Now, why are they there? Well, that's because T is the midpoint. Now, there's telling me that XT is 39.9, and they want to know what XY is going to be. So here's the thing. XT is congruent to TY. Okay, they are congruent because that's the midpoint. That means that their measurements are the same. Now, what is the measurement of XT? Well, it's 39.9 centimeters. That is how much TY is. So if XT is 39.9 and TY is also 39.9, then XY happens to be the sum of both XT plus TY because of the segment addition postulate. Or in other words, you're just doubling it. So 39.9 plus 39.9, we'll come back to our units in just a bit. XY is the sum of those two. Okay, so you can go ahead and add this in your head or grab your calculator. I really don't care. 39.9 times 2, or add this in. That's 79.8. And our units are centimeters. So that's example number 1. Here's example number 2. Point M is the midpoint of VW. Find the length of VM. Now here's the thing. If M is the midpoint of VW, that means that this segment and this segment, they're congruent. So here, VM is congruent to MW. Therefore, their measurements are the same. So the length of VM equals the length of MW. But what are their lengths? If you look at the diagram, it'll tell you. So VM is 4x minus 1, and MW is 3x plus 3. all we got to do now is solve for x. Okay, so we solve for x. Now, there's different ways of doing this. I like to always get rid of the term with the smallest coefficient in the x, the one with the variable. So we're going to subtract 3x, That gives me x minus 1 equals 3. After this, add 1, and x equals 4. Now, is that my answer? No, because the question is asking me for the length of VM. So they want to know, what is VM? Now, VM is equal to 4x minus 1. So what am I going to do? I am going to substitute the value of 4 in place of the x. So VM is going to be 4 times 4 minus 1. Clean that up a little bit. So that's going to be 16 minus 1, which happens to be 15. So VM equals 15. And that is example number 2. Okay, example number 3. Now, these two examples, the first part is pretty easy. The second part gets a little confusing for some people because it's asking them to work backwards. Okay, so let's look at it. For A, the endpoints of RS is 1, -3, and 4, 2. And they want to find the coordinates of the midpoint. So it's nothing new. We've done this already. So R is 1, -3, and S is 4, 2. By the way, my 5s look like S's and my 2s look like Z's. They will be like that all year long. So I'm sorry and I apologize for the confusion ahead of time. That's an S, by the way. All right, so we are going to use the equation for the midpoint. Now, the equation for the midpoint, we already know it's this one, x1 plus x2 over 2, y1 plus y2 all over 2. So all we're going to do is literally just plug the numbers in. Okay, so the coordinate of the midpoint is going to be the sum of the x's, that's 1 plus 4 all over 2, and -3 plus 2 all over 2. Now, when you solve for this, that's going to be 5 over 2. And this is going to be -1 over 2. Now, if they want your answer in fraction form, there it is. If they want it in decimal form, then divide it. That'll be 2.5 and -0.5. So in some problems, they might ask you for the fraction. Some problems, they might ask you for the decimal. It all really depends. Now, here comes the harder part. Let's look at B. Okay, for B, they tell you that the midpoint of JK is M. Okay, so in this case, M is the midpoint. Okay, M is the midpoint. It's this part. Okay, now they tell me that the other endpoint is J. Okay, now we're looking for the coordinates of the other endpoint, K. Now we don't know what that is. We really don't, but we know that the averages of these two x's divided by 2 equals that. We know that the average of these two equals that. Okay, so how are we going to do that? Well, we're going to call this coordinate x, y, because we don't know what they are. But I do know that 1 plus x, 1 plus x divided by 2 would kind of technically give me the x coordinate of the midpoint. And 4 plus y all divided by 2 would give me the coordinate of the y value for the midpoint. Now, if you look at it, we already know that. That's 2, 1. So this is the hard part, okay? Because remember, this is the midpoint. It was given to us. We're working backwards. It's not like this problem where they give me the endpoints and I found the midpoint, okay? So I should have called this one M. So here they give me M and I'm looking for the other one. So what I got to do is I need to match these up. So this is equal to this and this is equal to that. So I'm going to write it down here on the side. 1 plus x over 2 equals 2. 4 plus y over 2 equals 1. And now I got to solve for both x and y. Oh my gosh, a fraction. Ooh, bad. How do you get rid of fractions? Very simple. Get rid of the denominator by multiplying both sides. So if you multiply this by 2, you've got to multiply that by 2. So then these 2's divide out to give me 1 plus x equal to 4, minus 1, x equals 3. Do the same thing for this part. Multiply both sides by 2. Should give myself a little bit more space. And those divide out. That gives me 4 plus y equals 2. Minus 4, y is equal to negative 2. So ladies and gentlemen, we found the coordinates of the x and y for the other endpoint. So k, ladies and gentlemen, is 3, negative 2. So that is the endpoint we were looking for. A little more complicated. So if it helps, pause the video, go back and see it again. And that, ladies and gentlemen, is example 1.3. I mean, example 3, not 1.3. That's the lesson. All right, now this one's a little bit more complicated. Okay, so pay very, very close attention. Okay, so it says your school is 4 miles east and 1 mile south of the apartment. Okay, a recycling center where your class is going on a field trip is 2 miles east and 3 miles north of your apartment. Estimate the distance between the recycling center and your school. So what really helps here, guys, is a diagram. Okay, now the diagram that we are using is going to be a graph. So first thing, let's break this down into pieces. Okay, let's look for the school. The school is 4 miles east and 1 mile south of your apartment. And the recycling center, where your class is going on a field trip, is 2 miles east and 3 miles north of your apartment. So your apartment is where you start. That's 0. Now we need to remember north, south, east, and west. So we got to remember that. North, south, east, and west. Okay, so from your apartment, you're going to go 4 miles east. That's 1, 2, 3, 4. And then 1 mile south. Okay, that is where the school is at. Now, let's look for the recycling center, which we're going to call R. Now, you start again from your apartment, and it's 2 miles east, 2 miles east, 1, 2, and 3 north, 1, 2, 3. Okay. I'm going to zoom in a little bit on that so you can see. Now, what they want to know is what is the actual distance between the recycling center and the school. So let's look at the coordinates. S is 4, negative 1, and R is 2, 3. And they're asking me for the distance. So I got to use the distance formula. Okay, so now I know for the distance formula, I'm going to have to label them. So might as well do that right now. Half of the problem comes with the labeling. The second half is the substitution. So the distance is equal to x2 minus x1, y2 minus y1 squared. All you got to do is just literally plug it in and solve. All right, x2. x2 is 2, x1 is 4, y2 is 3, y1 is negative 1. Be careful, it's a negative. Don't forget the negative sign. Quantity square. So 2 minus 4, that's -6. Now, when you subtract from a negative, when you subtract a negative, that turns to addition, and that becomes 4 squared. So keep simplifying, and you're going to get 36 plus 16. Now, when you add those two, oh wait, I did something wrong. 2 minus 4 is not -6. That's -2. Minus una. Hey, happens to the best of us. So, yes, I made a mistake. That will happen a lot of times. That's 4. So now the sum is the square root of 20. Now, all I'm going to do is I'm going to go into my calculator and type that in. Okay, so the square root of 20 is about 4. Now they want to round to the nearest 10, so it's about 4.5. So guys, what kind of calculator are you using? I'm using this one, Dollar Tree. Best calculator ever for the cheapest price, and it's scientific. So if I were you, go to Dollar Tree, look for these. They're awesome. Okay, so that's 4.5. So the distance between R and S is 4.5 miles. All right, guys, so that is example number 4. Remember that I do take, I will convert these examples into a PDF and put them on Teams. So if you, for some reason, need to see these again, you can either watch the video again or go into Teams and see the pages that are in there. All right, have a good day.